So, for this episode, we're continuing with the theme of things I saw in Puerto Rico because, well, why not? On the last episode, I talked about a couple of birds that I saw. This episode, I want to talk about another bird, but also some non bird things. So, first, I'm going to tell you about another non native Puerto Rico species of bird, monk parakeets. Then I'll tell you about a crustacean, a crab called a Sally Lightfoot crab. And finally, we'll round out the episode with an insect. Although, truth be told, I didn't see the insects themselves, just their nests, but I learned some fascinating things about conehead termites. So without further ado, let's go back to Puerto Rico. I'm your host, Tim the Nature Nerd O'Hara, and this is the Dispatches from the Forest podcast. So let's talk just a little bit about monk parakeets. Monk parakeets are a small to medium bright green parrot with a grayish breast and a greenish yellow abdomen. They're native to the temperate and subtropical areas of South America, but thanks to the pet trade and either accidental or intentional releases of these pets, self-sustaining feral populations occur in many places in North America and Europe, mainly in areas of similar climate. In fact, as one of the few temperate zone parrots, monk parakeets are able to survive in cold climates. Now, this is partially attributed to their habit of building nests on warm electrical equipment, which, incidentally, can also create a serious fire risk. But here in the United States, there's thriving populations of monk parakeets in at least 8 states, including several large cities like Chicago, New York, Austin, Dallas, and Houston. In Florida alone, the population is estimated to be between 150 and 500,000. Now, monk parakeets are one of the few parrots that build a nest, and monk and cliff parakeets are unique even among nesting parrots because they build large external nests in trees or man-made structures instead of using tree cavities like other parrots. The monk parakeet is a gregarious species and often breeds colonially, and while some pairs nest outside of the colony, monk parakeets usually build a single large nest with separate entrances for each pair, sort of a parakeet apartment building. In the wild, these colonies can grow very large, and the nest can be the size of a small car. These nests also attract other tenants, including some that cohabitate with the monk parakeets. These tenants can include other birds like pigeons, sparrows, American kestrels, and yellow-billed teals, but also mammals like red squirrels. Monk parakeets also sometimes breed in groups, with one study finding that about 20% of monk parakeet breeding units are composed of 3 to 5 birds. These breeding groups can consist of both related and unrelated birds, and sometimes involve multiple females laying their eggs in a single nest. Now, monk parakeets are noisy birds, with a vocabulary that consists of at least 11 different types of calls, and here's just a few examples. But regardless of the type of call being used, it's thought that they have individual voice prints that let them recognize each other. And because they're as social and intelligent as they are, monk parakeets develop some cultural traditions, namely vocal dialects that differ between groups. In populations descended from a large number of birds, a range of these dialects can exist. But if the founder population is small, a process similar to genetic drift can occur when prominent founders vocalize in an unusual dialect. In that case, the particular way of vocalizing becomes established in the resulting feral colony. For example, the feral monk parakeets of the Milford, Connecticut metropolitan area have at least three distinct dialects. Okay, moving on from monk parakeets, let's get a little bit crabby. Now, while we didn't spend a lot of time at the beach during our time in Puerto Rico, we did spend at least some time there. And I'm not a huge beach person, but I do like poking around the rocks and tidal pools to see what I might find. And one of the first things I spotted during my beach time was a Sally Lightfoot crab, also called a red rock crab. A common crab in this part of the world, but new to me. They have a wonderful scientific name, Grapsus grapsus, which is essentially a Latin derivation of a Greek word and translates roughly as crab crab, and it's hard not to just call them crab crabs. These are small crabs. Their round, flat carapace only measures a little over 3 inches, 8 centimeters. Like most crabs, they have 5 pairs of legs, the front 2 of which are, of course, their claws. Young crabs of this species are black or dark brown in color, making them well camouflaged in the rocks and the black lava coasts of volcanic islands. Adults are more variable in color. Some are muted brownish red, others are mottled or spotted brown, pink, or even yellow. The one I saw was mottled black and tan, and it blended in well with the rocks, and had it not moved, I probably would have missed it. They feed primarily on algae, but will sometimes sample other plant matter, sponges, mollusks, crustaceans, including other crabs, fish, young sea turtles, bird eggs and their droppings, bat guano, and carrion. Interestingly, they have been observed in an apparent cleaning symbiosis, picking ticks off marine iguanas on the Galapagos Islands. They've also been known to resort to cannibalism when population densities are high or food is scarce. As larvae, they feed on phytoplankton. Now, before you get all hungry for crab legs, they're not considered to be very edible by humans. I mean, even whole shell and all, they'd barely be a mouthful, but they are used as bait by fishermen. Sally Lightfoot crabs are preyed on themselves by moray eels and also by octopuses. But they're incredibly agile, even capable of leaping, and consequently, very hard to catch. In fact, American novelist John Steinbeck observed them in the Gulf of California and wrote, quote, "They have remarkable eyes and an extremely fast reaction time. In spite of the fact that they swarm on the rocks, they are exceedingly hard to catch. They seem to be able to run in any of 4 directions, but more than this, perhaps because of their rapid reaction time, they appear to read the mind of their hunter." Unquote. All right, moving on from crabs, let's talk about termites. In many trees in Puerto Rico, and this was something we noticed when we visited Costa Rica too, there were what looked to be growths, like a burl, roughly the size and shape of a basketball. But these aren't burls, instead, they're the nests of conehead termites, a species of arboreal termite endemic to the neotropics. At the center of this nest, in heavily reinforced queen's chambers, lives the king and the queen of the colony, or kings and queens. Newly formed colonies tend to have multiple queens and kings, all living together in the same royal chamber. Slightly older colonies tend to consist of multiple queens, up to 33, but only a single king. Mature colonies become monogamous, with only one queen and one king. In the early stages of the colony, this strategy is advantageous because it lets the colony produce lots of workers in a short period of time, and the production of reproductive females, called alates, more quickly than if they were monogamous from the start. Now, the thickness of the nest walls decreases as you move away from the queen and toward the exterior, although if the nest is attacked by predators, then the walls will be reinforced. The largest nest ever identified weighed 61 3/4 pounds, 28 kilograms, and measured roughly 27 inches by 18 inches by 14 inches, 68 centimeters by 46 centimeters by 34 centimeters. Now, termites are an example of a eusocial insect. Like honeybees, termites and other eusocial insects develop large, multi-generational, cooperative societies that assist each other in the rearing of young, often at the cost of the individual's life or reproductive ability. In eusocial insects, the benefits of giving up this reproductive ability of many individuals is that it improves the overall fitness of closely related offspring. In many cases, termites included, individuals specialize to fill different roles in the colony. These roles are called castes. In conehead termites, as well as other termite species, there are three main castes: female reproductive elates, workers, and soldiers. And interestingly, different castes can have different physical characteristics. For example, the reproductive female elates have wings, and the soldiers have the ability to spew a noxious, sticky liquid when under attack, helping ward off a predator like an anteater and keep it from coming back. Conehead termites also display a high degree of aggression towards other conehead termite colonies. This implies that they can recognize their kin and distinguish between kin and not kin. Studies done on similar termite species show that they can detect scent on each other. Now, that said, sometimes individual colonies display relatively low aggression to each other, which can result in the fusion of the two colonies. But notably, these colonies still show massive aggressive towards other colonies, indicating that this is not a loss in aggressive behavior, but a failure to recognize the other colony as not kin. These low aggressive colonies are usually younger, with multiple reproductive individuals. So the theory is that they may have a broader range of what they consider to be acceptable odor clues, leading to the recognition of other colonies as part of the family. Okay, but here's where these termites get really interesting. Despite the fact that conehead termites are so territorial when it comes to other termites, or defensive when it comes to predators, studies have shown that the conehead termite interacts with many different organisms, including a bat that actually roosts in the termite's nest and various species of ants that cohabitate with the termite. Now, some species of ant will take over an abandoned termite nest. Others prey on the termites, and still others inhabit the occupied nests alongside the termites. And studies have shown that when cohabitating, nutrients flow both ways between the ants and the termites. Interestingly, in the case of one particular species of ant that cohabitates with conehead termites, neither ant queens nor termite queens have been found in the nests, but the larvae of all their castes and sexes have been. The conclusion is that both the ants and the termites are members of colonies that have numerous nest sites, so the queens, in essence, are living at their vacation home. The ants and termites are segregated within the nest and don't normally encounter each other. The ants actually plug channels at the boundary of the areas they occupy to maintain this separation. But on occasions when the ants and termites do come into contact with each other, for example, if the nest is broken into, they're rarely aggressive and tend to avoid each other instead. It's been hypothesized that the hydrocarbon content of their cuticles may have changed, allowing them to live together in relative peace. So basically, again, they smell like kin. The termites are thought to benefit from this association because the ants leave debris in the nest containing nitrogen, increasing the availability of this important nutrient in an environment where it's scarce. They may also benefit from the ants helping protect the nest from predators. The ants benefit because termite nests provide an ideal location to raise broods, especially reproductive castes. The climate is suitable, and the nests are easily defended against predators. It's also thought that the conehead termites produce antifungal compounds that would be beneficial to the ants. Now, the white-throated round-eared bat, a species found in South America, roosts inside the nests of conehead termites. Male bats excavate the roost, expending considerable energy doing so. But the payoff is that they're more reproductively successful, since a harem of females will join them in the roost. The termite nest is again an ideal temperature for raising young and provides protection from predators of the bats. The termites actually repair the damage made to the nest by the bat, so the male bat has to constantly maintain the roost. But once the bats leave, the cavity is filled in by the termites in just a few weeks. Scientists are currently investigating how is it that the bats are able to create and maintain these roosts without being attacked by the termites. Who knew that seeing a basketball-sized mound in a tree could take me down such a fascinating rabbit hole? And that's all for this episode, my friends. If you'd like to support the podcast, here's some ways you can do that. Become a patron. Subscriptions start at just $5 a month, and with 3 paid months, you get free Dispatches from the Forest merch. Find all the details at patreon.com/dispatchesfromtheforest. You can donate using either PayPal or Venmo using my email address, dispatchesfromtheforest@gmail.com, which is also how you can contact me if you have any questions, comments, or requests for future episodes. You can also donate using the Cash App and the hashtag ForestNerd. You're welcome to send a check, just message me for my mailing address. And of course, there's Dispatches from the Forest merch for sale. Go check out the merch store at cafepress.com/shop/dispatches from the forest, click on products, and see all that we have to offer. Finally, you can follow Dispatches from the Forest on Facebook, Instagram, TikTok, and YouTube. I'm your host, Tim the Nature Nerd O'Hara, reminding you to go outside and get dirty. Dispatches from the Forest recognizes that the lands where we live, work, and recreate are the traditional homelands of the Eastern Shoshone and Northern Arapaho people. We understand that this land holds immense significance for the original stewards, native nations, and peoples of this region. The Dispatches from the Forest podcast is a production of Dispatches from the Forest, may not be used or rebroadcast whole or in part without express written permission.